there's a generalization of sets which are called multisets. A multiset is like a set except repetition is allowed. So the two-element multisets of numbers 1, 2, 3 are 1, 1, 1, 2, 1, 3, 2, 2, 2, 3, 3, 3. So equivalently, I guess we could say these are weakly increasing sequences made with those elements. So there's 6 weakly increasing two-element sequences with components 1, 2, 3. Now there's only 3 strictly increasing sequences with these components. One, 2, 1, 3, and 2, 3. So sets can be looked at as, well, sets of numbers can be looked at as strictly increasing sequences, because in a set we never have any element repeated. And multisets can be looked at as weakly increasing sequences, because we are allowed to have elements repeated arbitrarily many times. Let's define n multi-choose k to be the number of k element multisets of an n element set. So apparently, by what we just did, 3 multi-choose 2 is 6, as opposed to 3 choose 2, which is 3. Now when we look at n choose k, n has to be greater than or equal to k, or else we get 0. We can't choose 5 things from a 4-element set if we're not allowed to repeat. On the other hand, 2 multi-choose 3 is not equal to 0, because we could take a 2-element set, 1, 2, and the 3 has the 3-element multisets 1, 1, 1, 1, 1, 2, 1, 2, 2, and 2, 2, 2. So apparently 2 multi-choose 3 is 4. Now there's a connection between n multi-choose k and n choose k. They're not equal, of course. But the connection is that n multi-choose k equals n plus k minus 1 choose k. So we can prove this bijectively. The left-hand side is the number of weakly increasing sequences A1 through AK with A1 is at least 1, and then every number is at least as big as what came before it. And the last number can't be any bigger than n. So this is a k-element multiset of 1 through n, or if you like, a weakly increasing sequence of numbers 1 through n. I want to interpret the right-hand side in terms of sequences too. So the right-hand side is the number of strictly increasing sequences let's say B1 through BK with, so B1 has to be at least 1, B2 has to be greater than B1 because it's strictly increasing, and BK can be at most n plus k minus 1. I want to show that these weakly increasing sequences line up perfectly with these strictly increasing sequences. So let's take weakly increasing A1, A2, A3 up to AK, and let's add 0, 1, 2, etc. up to, I guess we'll add k minus 1 to that last component. So if A1 and A2 were possibly equal, with A2 being greater if anything, and we add 1 to A2, then they can't possibly be equal anymore. So we'll get A1, which is less than A2 plus 1, which is less than A3 plus 2, strictly less than because we're adding more to A3 than we added to A2. And we finally get AK plus k minus 1. Now A1 is at least 1. Now if AK were at most n, then I guess this number is going to be at most n plus k minus 1. So now we have a strictly increasing sequence of numbers A1, A2 plus 1, A3 plus 2, etc. And these numbers are all between 1 and n plus k minus 1. So this sets up a bijective correspondence between things counted by the left-hand side and things counted by the right-hand side. Similarly, if we start with, you're probably convinced this is a bijection already, but if we start with this B sequence, which is strictly increasing, and subtract 0, 1, 2, etc. up to k minus 1. B2 is strictly greater than B1, so if we subtract 1 from it, at worst they could be equal. But B2 is not going to end up being less than B1 because we subtracted 1 because it was at least 1 greater than. So we get B1, which is less than or equal to B2 minus 1, which is less than or equal to B3 minus 2, etc., which is less than or equal to BK minus N minus K plus 1. B1 is greater than or equal to 1. And if BK were, actually we're subtracting K minus 1, so minus K plus 1. So if BK is less than N minus K plus 1, and we subtract, maybe it's easier if I write K minus 1 in parentheses, then we get something that's no greater than N we get something that's no greater than N. So that's exactly what we wanted to get, to compare this to weakly increasing sequences of numbers between 1 and N. At the end.